Hey folks, so today we are going to graph square root and cube root functions using a transformational approach. So let's get started. So let's go back and recall our quadratic function, our squared function. If we did that, if I graph that here, our 5 key points were 0, 0, 1, 1, 2, 4, negative 1, 1, and negative 2, 4 right here. And then we had our quadratic function going up like this, going up like this. Our domain was all reals, and our range for the parent function is 0 to infinity. Okay. So now we want to graph the square root function. Okay, and we need to think about how is this going to look. So the square root function, let's make a short little table, x, y. What would be good values to choose for x? Well, what are easy numbers for us to take the square root of? Well, those would be perfect squares. So 0, 1, and then the next easiest one would be 4. So I would get back out 0, 1, and then the square root of 4 is 2. So I put these right here. Now I'm going to plot my points. 0, 0, 1, 1, and 4, 2. And then our graph goes out like this. It starts at 0, 0. So what's the domain on this? The domain on this starts at 0 and goes to infinity. And the range on this also starts at 0 and goes to infinity. And so what we want to do is we want to think about, after you do this, let's think about what's the relationship between the squared function and the square root function. How are these two related? We've talked about this when we did our characteristics of functions. I won't go into it now, but think about this the next day or so. How could these two be related? In the same fashion, let's take a look at f of x equals x cubed and f of x equals the cube root of x. How might these be related? Well, let's graph these first. If you recall, our cube root function uses the points 0, 0, or excuse me, our cube function 0, 0, 1, 1, and negative 1, negative 1, and it looked like this. Okay, and the domain was all reals and the range was all reals. Now let's take a look at the cube root function. So let's just do another quick little table over here. Well, what would be numbers that are easy to take the cube root of? Certainly 0 would be 1, 1, negative 1, and then what's next? Well, the next easiest number to take the cube root of would be 8, and then negative 8 on this side. And then the cube root of negative 8 is negative 2, negative 1, 0, 1, and then 2. So let's see how this would look right here. So I have 0, 0, 1, 1, negative 1, negative 1. So notice it has the same 3 points as our cubic function, but the next one would be all the way over at 8 and then up at 2. It would be all the way over here somewhere, and then at negative 8, negative 2 would be over here somewhere. And so you can see it's headed in a different direction. This graph is actually headed like this. That sort of looks like a sideways version of our cubic function. Well, does the domain and range change? Well, the domain is still negative infinity to infinity, and the range would be the same thing. So take a look at these. Graphically, how can we relate these two? So think about that. So let's talk about actually graphing these with a transformational approach. So imagine I had this quadratic, which we did in our quadratics unit. I have an a value h and k here. So what did A do to our graph? Well, A was our dilation slash the stretch. What did H do to the graph? H was our horizontal shift. And what did K do to the graph? Well, K was the vertical shift. So we have A, H, and K again to graph using a transformational approach. So let's take a look at this. So we have our cube root. This is a cube root. So on our cube root function, we have these 5 key points, but these two we really don't use because they usually go outside of our graph. So the key points that we're going to use for the cube root are the same 3 points that we use for a cubic. We just need to remember the shape of the graph on how that one goes. So let's take a look at this. We'll graph it. What is the shift? Okay. All based on our transformations that we've done in the past, we know this is, since this is a -1, this is going to the right 1 and up 3. So 0, 0 moves to the right 1 and up 3. And then the stretch is 2. So instead of going over 1 and up 1, I'm going to go over 1 and up 2. Instead of going to the left 1 and down 1, I'm going to go to the left 1 and down 2. And then we need to remember what our basic shape of a cube root is, and it goes like this. Now we've graphed our cube root function. The domain on this is all reals, and the range is all reals again. So next up we have a square root function. So let's graph that. So our vertex, where does the point 0, 0? Because remember our key points for this were 0, 0, 1, 1, and then 4, 2. Well, think about why aren't we using any negatives? Well, since we're taking the square root, we can't take the square root of any negatives and still be real. So our smallest value that we can take the square root of is 0. So let's figure out where are these parent points going to get shifted to. Since this is a +2, that's to the left. So it's going to the left 2 and then down 3. So to the left 2 and down 3. So 0, 0 gets moved right there. And then what is our stretch? Well, our stretch is a half. So instead of going over 1 and up 1, I'm going to go over 1 and up a half. Instead of going over 4, like we did over 4 and up 2, I'm going to go over 4 and up 1. Because I did half of our vertical movement, half of our 2. So now this is our graph, and you can see it's been compressed by a factor of 1/2. So what is the domain on this one? Well, domain is left to right, so our domain here starts at -2 and goes on to infinity. And how about our range? Our range is at -3 and goes to infinity. That is our domain and range. All right, let's take a look at this one. We have a cube root. Okay, where does our 0, 0 get shifted to? Well, we have no horizontal shift. We're just moving up 1, so 0, 0 gets moved to right there. And how about our dilation? Well, our dilation is -3, so instead of going to the right 1 and up 1, I'm going to the right 1 and down 3. Instead of going to the left 1 and down 1, I'm going to the left 1 and up 3. So the negative is going to change the direction of this, and this is a cube root, so we're going to go like this. Okay, so it looks like that. So it flips over when we have a negative dilation. Our domain and range are still all reals, and they are always all reals for our cube roots. How about this square root over here? Hmm? Okay, where does 0, 0 get moved to? Well, this is just moving to the right 3, and there's no vertical shift, so it's just moving to the right 3. So 0, 0 gets moved to the right 3 right here. Okay, and instead of going over 1 and up 1, I'm going to go over 1 and up 3 halves. And instead of going over 4, and I'm off the grid now, instead of going over 4 and up 2, well, what's 2 times 3 halves? Well, it's just 3. 2 times 3 halves is 3. And so here's my function. What's the domain and range? Our domain starts at 3 and goes to infinity. Our range starts at 0 and goes to infinity. So folks, that is graphing cube roots and square roots. Again, this is just an addition to the transformations that we have done before. We're just adding 2 new ones in. So what I really want you guys to think about over this is to think about how are these two related and how are these two related. We will discuss it in class. All right, have a good evening or day or morning or whenever.